All right, we're now on lesson 2. Probably it's somewhere around Wednesday and Thursday of this week, somewhere around there. But we've already gone through page 11. So now we're going to move on to page 12. So if you would open to that first, we'll just start reading and talking about it as we go. So describing position in 2 dimensions, which is going to sound really weird to you, but you were able to describe the position of the picnic table in the park in 1 dimension. Remember yesterday's lesson where we had to figure out where is the picnic table in here and how could we use a reference point to find that or to tell someone where that is. So now we're going to do something a little bit differently. That was 1 dimension. Your cousin had to walk in only 1 direction to reach the table, but sometimes you need to describe an object's position using more than 1 reference direction. The city shown in figure 3 at the top is an example. To describe the position of a house in the city might require 2 reference directions. When you describe a position using 2 directions, you are using 2 dimensions. So if you look at that picture, which is the library, where is the library related to your classmate's home? Well, maybe you need to go left for 50 feet and then turn right for 200 feet. And so I'm using 2 directions, 2 descriptions of that. To describe a position on the map in figure 3, you might choose north and east or south and west as reference directions. Sometimes north, south, east, and west are not the most useful reference directions. If you're playing checkers and you want to describe the position of a certain checker, you might use right or forward as reference directions. If you're describing the position of a certain window on a skyscraper, you might choose left and up. That might be a better way, a better description using reference directions. If you live in Vancouver, I don't know about the rest of Washington, but if you try to drive in Vancouver and you're used to driving in California, you'll notice that everything is a number. And so it's a number, the streets are all numbers, and they're southwest, northwest, southeast, northeast, and when I first drove up from California, it drove me nuts. I think it's a big joke they play on Californians. But I had to learn very quickly what west, north, south, and east were. I have to know which direction, not just right and left. Go east, go west, go north, go south, or you'll end up not finding anything in Vancouver anyways. Portland is a little bit easier, I think. So I want you to think about this. There's a reading check here. What are 2 other reference directions you might use to describe the position of a building in a city? So I want you to think about that as we continue to read here. Locating position in 2 dimensions. Finding a position in 2 dimensions is similar to finding a position in 1 dimension. First, choose a reference point. To locate your classmate's home in the map in figure 3, you could use your home as a reference point. Next, specify reference directions, north or east. Then determine the distance along each reference direction. In the figure, your classmate's house is 1 block north and 2 blocks east of your house. And you can probably look that up. Be sure to study that little map up there. And another question for you then, how can you describe the position of an object in 2 dimensions? We'll be talking about that tomorrow. Go on to page 13. Sometimes you need to describe how an object's position changes. You can tell that the boat in figure 4 has moved because its position changed relative to what? The buoy. Motion which is another word for your list, motion is the process of changing position. So motion has to have a change in position. Kind of look at that picture for a minute and then go down to the last paragraph. Suppose a baseball player, this is distance and display, I'm sorry, I just skipped. Okay, let's go back to motion relative to a reference point. Is the man in the boat in figure 4 in motion? Suppose the fishing pole is the reference point. Because the positions of the man and the pole do not change relative to each other, the man does not move relative to the pole. I'm not putting any distance between the pole and me. So that's not movement. That's not there's no motion there. Now suppose the buoy is the reference point. Because the man's distance from the buoy changes, he is in motion relative to the buoy. So you can be in motion relative to something and then not in motion relative to something else. So if I'm holding my cup of coffee, I'm not moving relative to my cup of coffee. But if that's my reference point, if it's the coffee cup and me, there's no movement. However, is the coffee cup moving relative to the computer screen? As I lean back and take a drink. Sorry, yes it is, because it's moving in relative to the screen, but not necessarily relative to me. So you can be doing both. Go to the bottom. Suppose a baseball player runs the bases as shown in figure 5. Distance is the length of the path the player runs as shown by the red arrows. Displacement, though, is way different. Displacement is the difference between the first position and the last position. It is shown in the figure by the blue arrows. Notice that the distance and displacement are equal only if the motion is in one direction. So if I take off from home plate and I don't know how to play baseball and I just keep running past first base and into the outfield and then finally into the parking lot, then that's my distance, and my displacement, if I were to keep running, is going to be the same as distance. But if I know how to play baseball and I am running the bases, so I started at home plate and I pop the ball out there really well and I start running, I run to first base, I run to second base, I run to third base, I run home, there's been no displacement because I'm back where I started. So the distance between my beginning point and my end point has not changed. And that's going to be something that we're going to talk about in class, just to make sure that you understand. And I think you will by the time we get done talking about it. So be thinking about that. And that's it for today. So make sure that you put those words into your Quizlet. If you're doing that, I think it still would be really smart if you did that. And we'll see you tomorrow in class.